no trick. If Nemo went to the edge of the reef and managed to survive, catching Nemo would not be difficult. When I was doing my research, I just needed one little aquarium net to pick them up. They are very easy because they live in an anemone. They have no defenses other than diving into among the tentacles of the anemone. So, how is that possible? They dive in among the tentacles touch them, the tentacles are filled with nematocysts. Anemones can capture fish as big as anemone fish or even bigger. How do these fish manage to live there? Well, we often say they're immune to being stung. They are not immune. And if there's one thing I'd like you to take away from today's talk, it's that the fish are not immune to being stung. What is the secret of the symbiosis is the slime on the fish, the mucus on the fish. If you rub that mucus off the fish and put it in the anemone, it's stung. It'll be eaten. And so the debate in science has been over what's the source of the mucus. We know fish are slimy animals. They produce a lot of mucus. But anemones are really slimy animals, and they produce a lot of mucus. So one of the hypotheses is that when an anemone fish first comes to an anemone, it sort of goes through a little dance and it touches its belly, and the tentacles actually cling. Nematocysts are discharging, but it pulls back, and then it touches its flanks, and the tentacles cling. But finally, it's not, the tentacles don't cling anymore. And one of the hypotheses is that it's coating itself with the anemone's mucus. And so the anemone doesn't perceive the fish as a fish. It doesn't sting its own tentacles. It's just not stinging the fish for the same reason. And in fact, if you watch anemone fish in nature, you'll notice that they never stay out of their anemone for more than 20 seconds. They'll swim up, they'll grab food, plankton, out of the water, they'll come down to their anemone. The other hypothesis is that the mucus of the fish itself doesn't stimulate the nematocysts to discharge. And there's evidence for both hypotheses. And I told you there's a wide variety in the fish-anemone combination. So in the specific combinations, it's probably the fish's mucus. And in the generalist combinations, it's probably the anemone's mucus. So there's evidence for both hypotheses. So, as I've said repeatedly, outside of the anemone, the fish have no defense, and so they never stray very far. So as I said, they go up, they catch some food, they come back. So the truth is, Nemo would never have gone to the edge of the reef. And if he had, he never would have survived. And so certainly, Dad or Mom or whoever it is now would never have survived to swim to Sydney. So, in short, if we had all of these nice animals swimming down to Sydney, see, I'm in a comedy club. I got it right. Okay. So, in nature, we never find anemone fish without an anemone. That is, in science, we say this is an obligate relationship. The anemone the fish must have an anemone in order to survive, for the reasons that I've been telling you. On the other hand, these 10 species of anemones, when you go to find them in nature, usually have a fish, but sometimes you can find one that doesn't. They can survive without a fish. So we call that relationship facultative. They don't depend on having a fish for all species. But in some places, the fish in the anemone is more important than in other places. This is the sort of star of the show. This is Heteractis magnifica. It's really a brilliant animal. I understand from Aquarius it's difficult to keep because it likes to climb up to the high points of an aquarium and often gets sucked into intake valves. But it does the same thing in nature. It's up on top of prominences, and because its column can be pink like this, or it can be red, or brown, or white, or blue, it's widely photographed. It's probably the most photographed species of sea anemone in the world. And these things can be very big. They can be almost as large in diameter as the top of this table. Among the largest of the so-called giant sea anemones. And this is a picture taken by a colleague of mine in the Maldives shortly after fish collectors left. So fish collectors came, they took the anemone fish, I said, it's no problem at all to catch the anemone fish. And within half an hour, butterfly fish had moved in, and they're eating this big anemone. So in this case, this provides evidence, and I did some experiments to document it in this species and others, that in these cases, the fish can be really important to the survival of the anemones. And in some places, they may even be essential. So in some places, the fish is as important to the survival of the anemone as the anemone is to the survival of the fish. And so this is another reason not to use wild-caught fish, because that could be causing the anemone to be defenseless and to be preyed on. And these butterfly fish are always patrolling, they're always watching. So people say, but how can that be? The anemones have nematocysts. Well, what's the natural diet of many butterfly fish? Corals. We don't know what protects them against being stung by coral nematocysts, but somehow they've adapted. And so when they see an anemone like this and they eat it, it's like boneless chicken. They've got a meal just sitting out there waiting for them. So they patrol and they know every anemone in their territory and know if there's a fish to protect. So in this case, we have a true mutualism. The fish is as dependent on the anemone as the anemone is on the fish. So, here's the story. Mom and Dad had 100 babies, that's believable, although most of them have more. And a pair of anemone fish will lay 300 to 400 eggs every 2 to 4 weeks, depending on the species, throughout the year in the equatorial tropics, during the summertime in the subtropics. After mom and 99 babies are eaten by a barracuda, which is possible, then Dad cares for Nemo. Well, it's believable, but only before Nemo hatched from the egg. And then Nemo rebels against his parent and is caught and put in an aquarium in the dentist's office. It happens all the time. My dentist's office has one, doesn't yours? Except for the rebellion part, of course. And then the parent and friends swim to Sydney to find the rescue Nemo, and that's impossible, of course, but it makes a nice story. So, a little more amplification on the anemone fish symbiosis. This is the only instance of fish living with the sea anemone. There are these little black and white fish that occur on coral reefs. And for the most part, people who studied anemone fish have sort of swept them away. They try to ignore them. Because these damsel fish are facultative symbionts. Not all of them live with an anemone during their lives, and those that do so only when they're very small. So it's clear that the anemone is protecting them. When they get bigger, they swim away. They don't live with the anemone any longer. And then we have this curious cold water anemone. This is an anemone that lives off the coast of Washington State and British Columbia, and was studied by a Canadian in British Columbia. And there's this little fish called convict fish, because it's black and white, so Oxylebius. And this fish is doing the same thing as an anemone fish. It's sitting down on the tentacles. And this fish lives and sleeps in an anemone when it's little. And it comes back every night to the same anemone. And as it grows, it comes less and less frequent. And finally, it stops coming at all. Not because it's gotten bigger than the anemone, because it can protect itself. So again, the anemone is really protecting the fish, and in this case, it's essential during a certain part of the fish's life. So, now here's a question for you. If the movie Finding Nemo was to release Nemo from his horrible captivity in the artificial environment of the tank so he could go home, then why does every kid want an anemone fish after seeing the movie Finding Nemo? This puzzles human psychology, I guess, but I study anemones, not humans, so I don't know. And one of the problems that has reared its ugly head with people getting aquarium denizens that they decide they can't keep any longer is the possibility of the fish then being released into habitats where they're not needed. Because the oceans are all connected, and so it might be justifiable for people to say, oh, well, it's an ocean. But we now know that, and there are various stories how this happened, that lionfish, which have exactly the same distribution natively as anemone fish, now are occurring off the east coast of the United States and the Caribbean. And this is one of the very, very first records of this, and this was recorded in 2004. Now, of course, people are trying to make them a gourmet item so they will be caught and they will be eaten, and we can overfish them like we have so many other fish and get rid of them. But they are really causing damage to the ecosystem as far north as New Jersey and into the Caribbean, because somebody saw a little, presumably, a little lionfish and thought it would be beautiful in the aquarium because it got bigger and it was attacking other animals and maybe stinging the owner. They dumped it into the ocean. There's a story that during some of the hurricanes, some tanks broke and the animals were released. However they got there, aquarium fish are being released into inappropriate habitats, and this is causing havoc. And we know that the anemone fish can live in exotic anemones, some of them, and it's possible that if anemone fish got released in the Caribbean, they might be able to take it there. And part of the reason for this, I think, is that we do a really poor job of teaching biogeography. In our biology classes, it's sort of like the cartoons you always see of the polar bear and the penguin together. And people believe that. They live in the same place. Of course, they live at opposite ends of the earth. It's sort of like this. This American Airlines ad implies if you go to Cancun or Cozumel or Ixtapa, anywhere in Mexico, you're going to see these. Does anybody know what these fish are? They occur in the Red Sea. Yeah, the blue-cheeked butterfly fish is a native to the Red Sea. That's the only place you can find them natively in the ocean. And here, of course, our symbol of the tropics, the anemone fish, down here, advertising cruises to the Caribbean or Europe or the Panama Canal. I suppose if you go to the aquarium, you'll see which one. That's about the only place. So, the ultimate moral, I think, of the real story of Nemo is that in nature, an anemone host is essential for an anemone fish. But collecting the anemones diminishes not only the future population of anemones, but it also diminishes the clownfish. Because the clownfish have to have it. So you're taking away their habitat. And because of this conveyor belt effect, that when you remove it, then you're disrupting this whole cycle for potentially a century or more to come. But on the other hand, Nemo was fine in the surface. And anemone fish are easy to breed in captivity. You don't have to take them out of nature. And since the anemone was left on the Great Barrier Reef, could be lived in by other anemone fish, what was the problem? Why did we have to release them? So this is just a little plug for my work, and then a thank you to all the people who helped, and I'll be glad to take your questions now.